There are two styles of polynomials that we're going to look at for dividing polynomials. The first style is when we have a monomial in the denominator. A monomial in the denominator would be something like a plus b plus c all over d, where there's just one term in the denominator. If this is the case, you can divide your polynomials by splitting it into separate fractions for each piece. So we would split our numerator into 3 separate fractions, each over our denominator. And then we could simplify. So for example, if we have 6ab c to the third minus 5a to the second b to the third c to the fourth plus 13a b to the fifth c all over 3a b to the second c to the third. There are a lot of pieces in that monomial. There's a lot of pieces in this monomial, but it is only one term. There is no addition or subtraction, so it's a single term, so it's a monomial. So that means we can separate the numerator into 3 parts, one for each term, all over our denominator. So for example, we would have 6a b c to the third over 3a b to the second c to the third minus 5a to the second b to the third c to the fourth all over 3a b to the second c to the third plus 13a b to the fifth c all over 3a b to the second c to the third. We took our numerator and split each piece into its own fraction all over the denominator. Now we can simplify. 6 over 3 we can reduce to 2. A over a is going to cancel. Here we have b to the first over b to the second, which will simplify to 1b left over in the denominator. C to the third over c to the third will cancel. We have our subtraction from right here. 5 over 3, we can't really do anything with that, so it remains 5 over 3. We have a to the second in the numerator over a. 2 minus 1 is 1, and there were more in the numerator to begin with, so it stays in the numerator. Then we have b to the third over b to the second. 3 minus 2 is 1, and there were more in the numerator, so it stays in the numerator. C to the fourth over c to the third will simplify to just c in the numerator. Then we have plus 13 over 3 we can't really do anything with, so we're just going to leave that for our fraction. A over a is going to cancel again. B to the fifth over b to the second. Well, 5 minus 2 is 3. There were more in the numerator, so they stay in the numerator. And then we have c over c to the third, which will leave us c to the second in the denominator. Let's try again. Number 2. 4x to the 13th plus 12x to the 6th minus 11x to the 5th all over 4x to the 4th. So we can split our fraction with each piece having our denominator of 4x to the 4th. We have 4x to the 13th over 4x to the 4th plus 12x to the 6th over 4x to the 4th minus 11x to the 5th over 4x to the 4th. And then we can simplify. 4 over 4 reduces to just 1. 13 minus 4 is 9, so that leaves us with x to the 9th in the numerator. 12 over 4 is 3. X to the 6th over x to the 4th. 6 minus 4 is 2, so 3x to the 2nd. 11 over 4 we can't really do anything with, so we'll just leave that as 11 over 4. X to the 5th over x to the 4th leaves us with just x in the numerator. We will not always have a situation where you have just a monomial in the denominator. So let's look at what to do when you have something that is not a monomial. So let's say we have 12x squared minus 17x minus 7 all over 3x plus 1. See how we have a binomial now? We have that addition, so we have two separate terms. We have the 3x and we have the 1. So we cannot split this. So what we do is use long division. So in order to set up the long division, you pretend a strong wind comes, blows over the top, and that leaves you with 3x plus 1 in the front. And then we have 12x squared minus 17x minus 7 goes inside. So the piece right here goes to the front. The piece that was the numerator goes inside. Now what we're trying to figure out is how we can divide this into this. So you look at one piece at a time. Before you start dividing, make sure over here that you have your descending power of x's with nothing missing. Here we have x to the second, to the first, and then no x's, so we're good. Then look at your numbers. I have 3, I have 12. I need to figure out what times 3x is going to give me 12x squared. Well, 3 times 4 is 12, x times x is x squared. So 3x times 4x will give me 12x squared. You need to line everything up in columns. This is my x column, so if I need 3x times 4x, I'll line that up in the x's. 3x times 4x, taking our 4x right here, multiplying it right here. 3x times 4x is 12x squared. 4x times positive 1 is positive 4x. We can subtract these, and then we can simplify. 12x squared minus 12x squared is 0. Those cancel out. Negative 17x minus 4x. Don't forget your subtraction out here. Negative 17x minus 4x is negative 21x. Bring down your next piece and do the same thing again. So now we need to figure out what times 3x gives us negative 21x. Well, 3 times 7 is 21. A positive times a negative is a negative. So 3 times negative 7 is negative 21. I already have the x right there, so it looks like we just need minus 7. Now let's check it. Negative 7 times 3x is negative 21x. Negative 7 times positive 1 is negative 7. We'll subtract. Negative 21x minus negative 21x, that's 0. Negative 7 minus negative 7, that's 0. So we're finished. So up here, 12x squared minus 17x minus 7 divided by 3x plus 1 is going to give us 4x minus 7. Let's try again. There we go. So let's look at this as we consider it through. So our top blows off. We have 2b to the second minus 3, and then that is divided by, we have 4b to the fifth, and then notice we have 3, 2, 1, and 0. But notice that we're missing the b to the fourth right here. So we're going to squeeze that in. So we have 4b to the fifth plus 0b to the fourth minus 18b to the third plus 14b to the second plus 18b minus 21. Now we also need to check this part right here. We have b to the second, but we have no b piece, so we need to add that in. So that would be 0b. And then we have our 2b to the second. So we had some extra terms that we needed to add in this time. And now we can start our division. So we need to think about what times 2b to the second is going to give us 4b to the fifth. So look at one piece at a time. 2 times 2 is 4. B to the second, I need b to the fifth, so that means I need to multiply by b to the third. So if I have 2b to the second, and I multiply that by 2b to the third, I'll get 4b to the fifth. Let's check and see. So 2 times 2 is 4. B to the third times b to the second gives us b to the fifth. Let's put it in the right spot. There we go. And then continue down through. 2b to the third times 0b to the third is 0b to the fourth. 2b to the third times 0b to the first. 2b to the third times 0b to the first is 0b to the fourth. 2b to the third times negative 3 is minus 3 times 2 is 6. B to the third. Notice everything lines up. B to the fifth, B to the fourth, B to the third. It's important that you keep everything lined up. So let's simplify down. 4b to the fifth minus 4b to the fifth is 0. 0b to the fourth plus 0b to the fourth with our subtraction is 0. Negative 18b to the third minus negative 6b to the third. So that'll look like this. Negative 18 minus negative 6. So add the opposite. And it's going to give us negative 12b to the third. Bring down your next piece. So plus 14b to the second. Bring down your next piece. Plus 18b. Now let's do the same thing again. So this time we are looking at 2b to the second and negative 12b to the third. So what times 2b to the second will give us negative 12b to the third? Well, 2 times negative 6 will give us negative 12. B times b to the second will give us b to the third. So that means we need negative 6b. Notice how we lined that up in the b column. There isn't anything here, so we can go ahead and put in our 0, b to the second. We have to line it up. So b column is right here, so negative 6b goes there. So let's multiply it down and see if it works. So negative 6b times 2b to the second, that gives us negative 12b to the third. Negative 6b times 0b, that gives us 0b to the second. Negative 6b times negative 3, that gives us positive 18b. Now we're subtracting. Negative 12b to the third minus 12b to the third, that's 0. 14b to the second minus 0b to the second, that's 14b to the second. 18b minus 18b, that's 0. And then don't forget this 21 that we need to bring down, minus 21. So let's look again. Now I have 2b to the second and 14b to the second. So what do I multiply by 2b to the second to get 14b to the second? We need to multiply by positive 7. 7 times 2b to the second is 14b to the second. 7 times 0b is 0b. 7 times negative 3 is negative 21. 14b to the second minus 14b to the second gives us 0. 0b minus 0b gives us 0. Negative 21 minus negative 21 gives us 0. So no remainder. And that means this right here is our result from our division. Let's try again. X to the third minus 4x plus 1 all over x minus 3. So when we move our top over, we're left with x minus 3. But as you go to write this, notice you're missing the x to the squared piece. So we need to put a 0 as our placeholder. There we go. And then we have to look at it. What times x gives us x to the third? Well, x to the second times x gives us x to the third. So that means we need x to the second. Line it up in our x to the second column. X to the second times x gives us x to the third. X to the second times negative 3 is negative 3x to the second. we're going to subtract. X to the third minus x to the third is 0. 0 minus negative 3, that's going to look like this. So 0 minus negative 3, so add your opposite. So that's going to give us 3 x to the second. Bring down your next piece, and then we can go again. I have x. I need 3x to the second. Well, 1 times 3 gives us 3. X times x gives us x to the second. So plus 3x. 3x times x is 3x to the second. 3x times negative 3 is minus 9x. We're subtracting. 3x to the second minus 3x to the second, that gives us 0. Negative 4x minus negative 9x, that's going to look like negative 4 plus 9. So that's going to give us 5x. Bring down your next piece. So now we do the same thing again. What times x gives us 5x? Well, this is technically a 1. So 1 times 5 is 5. So here we need plus 5. 5 times x is 5x. 5 times negative 3 is negative 15. We can subtract. If we subtract 5x minus 5x gives us 0. 1 minus negative 15, that gives us 16. Now notice we didn't get 0 this time. In the last couple examples, we had 0 once we finished our division. This time we didn't get 0, so this is what's called our remainder. So to write the remainder, you put it right next to it. It's a positive, so I'll do plus. And it's 16 over x minus 3 from right here. So that is the result of our division. Let's try again. Let's say that I give you f of x equals 18x squared minus 24x, and g of x equals 3x. So let's find f over g of x. So that means we're asked to divide. F is this one, g is this one. So that would look like 18x to the second minus 24x all over 3x. We have a monomial in the denominator, so I can split this into two separate fractions. 18x to the second over 3x minus 24x over 3x. And then simplify each fraction. 18 over 3 is 6. X to the second over x is just x. 24 over 3 is 7. X over x cancels. Now we need to be careful. In this one, what numbers could we not use in our domain? Well, in this case, our domain is our g of x. So our g of x is what is going to give us restrictions in that denominator. So we're okay with any values right here in our domain other than when 3x would be equal to 0. So our restriction is 3x cannot equal 0. So that means x cannot equal 0. So if you're asked to find the domain, in this case, yes, this is what you get when you divide. But we have to keep in mind that the domain for this one is x cannot be equal to 0. Let's try one more. Let's say you're given f of x equals x squared minus 9 and g of x equals 2x. Let's find f over g of 2. So this means instead of finding of x, we want f over g of 2. So f is x squared minus 9. G is 2x. Now we could go through the same process with our monomial in the denominator here, but we know what our x value is. So let's go ahead and put our x value in to save us the work of having to rewrite it all. So instead of our x, we're going to put a parenthesis, and in that parenthesis, we're going to put what we're told x should be, in this case 2. 2 to the second gives us 4. 4 minus 9 is negative 5. So f over g of 2, which means f divided by g, with a value of 2 instead of the x, gives us negative 5/4. Let's try one more. Let's switch this around, and let's do g divided by f, and this time instead of x, let's look at 0. So g becomes our numerator, f becomes our denominator, and instead of that x, let's put in a parenthesis, and inside that parenthesis, we're told that we should be using 0 in this case. So 2 times 0, that's just 0. 0 minus 9, that's negative 9. Now be careful. 0 is in the numerator this time. It's not in the denominator, it's in the numerator. 0 in the numerator is a perfectly valid answer. It just means that the result here is going to equal 0. 0 divided by negative 9 gives us just a value of 0.